Sorry, I added them first.
All right, so
No, I didn't.
all right, hey,
Person who lost the fantasy.
here we go. Questions on the first one, guys. How many license plates with 4 letters followed by 3 digits? Here, 26, 26, 26, 26, because you can repeat the letters, and then 10, 10, 10, because you can repeat the digits. Okay? You can see everything. Okay? All right. If you're not allowed to repeat, now you could use NPR, or you can continue with this, because both work. Carter,
I was just going to tell you that when I did.
what would you do?
26 times 25 times 24 times 23. So then you do times 10 times 9 times 8.
Okay, so you can use the multiplication counting principle on this one as well. How many letters could go in that first spot? 26 of them. But once you use the letter, now there's only 25 left for you to use, so that's why there's only 25 letters left in that next spot to go. Okay? Also, you could use NPR on this. There are 26 letters, and you're putting 4 of them in a certain order in those first 4 spots. And then however many possibilities that is, then you take that times 10 NPR 3, because you have 10 digits and you're putting 3 of them in a certain order that follow those letters put in a certain order. So if you would take this times this on your calculator, this is the math you end up doing. I don't care what makes most sense to you, using NPR or the multiplication counting principle, both will definitely work. Okay, any questions on that? Okay, all right. How many 5-card hands from my 52 deck of cards could you be dealt? What would you do, Brady?
52 NCR 5.
52 NCR 5. Why do we use NCR?
Because order doesn't matter.
Because order does not matter. Okay? These are combinations. You use NCR when you do getting a deck of cards, when the order that you pick the cards up from your hand doesn't matter, whatever order those cards came in, it's still your hand of 5.
So this next one would be 52 NCR 5.
Royal flushes are a lot less common.
All right, hold on. I got a question here. Go.
Order matters.
Sure? Okay. Any questions on this one? Okay. Then this one is just kind of an extra throw in here. A royal flush is when you get an ace, a king, a queen, a jack, and a 10 all in the same suit. That is like the big time winning hand when you're playing poker. Okay? How many royal flushes could a person be dealt? 4. You either get a royal flush in hearts, you get a royal flush in diamonds, in clubs, or in spades. There are no other royal flushes out there, because as soon as you start mixing suits, it's not a royal flush anymore, it's just a simple straight. Flush is when all the suits are the same. Okay? So it'd just be a straight otherwise. Okay? There are only 4 royal flushes. Okay? 1 in each suit. Alright? So, that great point. If I asked you, I got out a deck of cards and I dealt you 5 cards, what is the probability that you get a royal flush dealt to you? You don't need to tell me the math or tell me what you would. The answers are
4
up
out
here.
of 2 million.
4 over what number?
52.
That one. Okay? Which you were saying the number, yep, that's fine. Because there's only 4 outcomes that are royal flushes, and this is how many total outcomes there are when you get 5 cards dealt to you. So the probability of you being dealt a royal flush is 4 out of that over 2.5 million number, or whatever you guys are saying. Okay? Very small, obviously. Okay? That's why you win a lot of money if you ever get dealt a royal flush playing poker. Okay? All right. Those are just a few of them that I wanted to go over with you. Those are a few questions too that may show up on a quiz. Okay. How about stuff from the combinatorics worksheet? the counting principle, the permutations, the combinations, and then just everything in general on the back. What can I go over with you?
Number 11 probably.
Oh, yeah.
Okay? As long as we're gonna talk about number 11, let's talk about NPR, okay? Because this will be a good lesson about it, okay? NPR tells you the number of ways you can arrange R items when there's a total of N items to begin with. For example, 8 people running a race. How many ways could I put them in first, second, and third place? NPR. Okay? I have 26 letters in the alphabet. I'm going to create a 4-letter code. How many different 4-letter codes could I create? 26 NPR 4, assuming you can't repeat a letter. Okay? The formula that your calculator uses for this, we talked briefly about yesterday. Okay. Now, why does that work? Okay. Well, let's go back to that 8 people running a race thing. Okay. Let's go back to that 8 NPR3. The reason it works is quite simple. It really relates back to the multiplication counting principle that we've mentioned before. Okay. If we do 8 factorial over 8 minus 3 factorial, I wrote this out yesterday, didn't I?
Yeah.
8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That would represent how many ways you could arrange all 8 runners. If I said, how many ways could the runners finish first through 8th place? This would be the answer. Because how many people could come in first? 8. How many then could come in second? 3rd, 4th, 5th, so on, right? Okay? But do I care about them coming in first through 8th? No, I only care first, second, third. Okay? So, it doesn't matter about all of these back here, right? So that's why we simply divide by that. 8 minus 3 is 5. So you're dividing all of those out because you don't care about the order of the last 5 spots. Okay? So you would just get 8 times 7 times 6. That would tell you how many ways they could finish first, second, and third. Is it n minus 3, Noah?
Yeah.
Okay. Well, let's see what this equals. In factorial. What math would you have to do in factorial? N times n minus 1 times n minus 2, n minus 3, n minus 4, all the way until you get down to 1, right? If n is 100, then you do 100 times 99 times 98 times 97, all the way down to 1. Yeah? My alphabet. Okay. Good?
Yep.
Okay. All right. So that's what I would have to do n factorial. Now, n minus 3 factorial, what would I end up doing? Like when I had 8 minus 3, I had that number times every number below it, right? So n minus 3 times n minus 4 times n minus 5 times all the way down to 1, right? Well, what would end up happening? Everything would what? Cancel out, right? Cancel, cancel. Cancel, cancel. Is there an n minus 5 up here somewhere? Yeah, we just didn't write all of them. N minus 6s, n minus 7s, they'd all cancel out all the way until down to the number 1, right? What are you left with? n times n minus 1 times n minus 2. So this would equal this right here, based on the math using factorials. Okay? So this permutation rule right here basically just ends up you taking n times all the numbers below it until you've gotten to that many numbers. You know, like 8 NPR3 means start at 8 and multiply the next, or 3 digits together. 8 times 7 times 6. Because you only care about the first 3 spots, the first 3 numbers. But you are putting them in a certain order. So there's 8 different things that could go in the first spot, then 7 different things in the next, and then 6 in the next. Okay, so that's NPR. Doesn't that help on 11? Okay. Now, NCR is different. NCR is this. Looks almost the same, but it has an extra r factorial right here. Why? Yep, it shows the order doesn't matter because what it's doing is it's dividing out all of the ways you could have selected those same 3 things. Okay? So if I did 8 NCR3, you would do 8 factorial over 3 factorial times 8 minus 3 factorial. When would I use 8C3? I have to I have 8 people in my class. I need to select 3 of them to go with me on a field trip. Does the order I select the 3 people matter in that instance? No. But if I said I need to select 3 people to be president, vice president, and secretary of some committee, then would it matter? Yes. So then I'd use 8 NPR 3 if I had to put them in a president, vice president, secretary position. But if I just had to select 3 of them to be on a committee or to go on a field trip with me, the order doesn't matter. So all of those different ways that I could select those 3 people, all the different orders, I'd have to divide all those out of there because the order doesn't matter. That's why it's got this extra r factorial in it, because it's dividing out all the extra ways you could arrange those 3 people. Questions on NCR? This r factorial right here is dividing out all of the ways those r number of people could have been selected. Okay, any questions on that? Okay, how about other questions in general from the practice?
For number 9, wouldn't you just do like the 6 times 5 times 4 times 3 times 2 for like the letters? Or am I doing that wrong?
Number 9.
We have to do that.
Probably didn't.
And how,
Oh.
the one that says, in how many ways can 3 identical emeralds, 2 diamonds, and 2 opals be arranged in a row in a display case? That one?
Yeah, and then it says like find the number of ways the letters each word can be arranged. 9A.
Oh, that's actually a 10. For some reason, the 10 didn't come out there. But find the number of ways the letters of each word can be arranged. That's when there's repetition of letters. Yeah, you don't, I'm not going to ask you to do those. But what you would do is when you're arranging things that are identical, okay, there are 6 letters in the word added. So 6 factorial would be the number of ways you could arrange all 6 of them. Well, there's 3 D's though, so those 3 D's can be moved anywhere around, and you won't, so you divide by 3 factorial. Yep, so you, in 10A, you do 6 factorial divided by 3 factorial. In 10B, you do 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 factorial divided by 5 factorial because there's 5 E's. In 10C, you do 5 factorial divided by 2 factorial times another 2 factorial because there's 2 R's and there's 2 O's.
So it'd just be 5 rather than.
How come you wouldn't add those 2 together? How come you would make a 5 or 4 factorial instead of, well, never mind.
Because that said you have to be a different math. Yep. You couldn't just add them or multiply them either.
But technically.
But that one works.
True.
Yeah.
That one works. But like 3 factorial times 2 factorial is definitely not 6 factorial. Okay. But again, that's not anything I'm going to ask you specifically. What else on here?
B.
17B. In how many ways can a committee of 7 be chosen from 9 girls and 8 boys? So I got 9 girls, I got 8 boys. I need to select 7 to be on a committee. Okay? Does the order matter? No, not at all. So I'm definitely using what? In CR.
7 overall.
Okay? Yep, I gotta select 7 overall people to be on this committee. Out of these 17 individuals. Okay? 17A says if all are equally eligible, then what would you do?
17C.
17C7. Okay, for A, you do 17C7. I know you asked about B, I'm getting there. Okay? Because if it doesn't matter whether you're choosing boys or girls, I mean, you got 17 total people and you got to form this committee of 7. The order you pick those 7 people does not matter. 17 NCR 7. Okay? The committee must include 4 girls and 3 boys. Okay? Well, then I'd kind of separate it. You got to choose 4 girls. So you split up the girls. And you choose 4 of them. How many ways could you choose those 4 girls? 9C4. Why? 9 girls. And you're choosing 4 of them.
Order doesn't matter.
Okay, order doesn't matter. So 9C4 would represent every possible 4-girl combination that could have been selected from those 9 girls.
And then would you take that times 8C3?
But every one of those combinations of 4 girls could be paired with a different combination of 3 boys. Well, how many different combinations of 3 boys are there? 8C3. So every one of those could be paired with every one of those. So you multiply them together to get the total number of combinations that there are if you had to choose 4 girls and 3 boys to make up this committee of 7.
That's a lot.
Oh yeah. Okay. So that all right?
Yes.
Okay, others? Some people just need some time to do them.
What about number 1?
Okay.
The even.
Sure. So now, this one says how many even 3-digit positive integers could be written using the digits 1, 3, 4, 5, and 6. Okay? Are we able, it doesn't say, but I'm going to tell you you're allowed to repeat numbers, okay? You're allowed to repeat any of those digits. Because we're allowed to repeat, can we use either of these? Think back to this. If we're allowed to repeat, don't we just do this?
Yeah.
Okay? We're creating a 3-digit number, right? So I'm going to go 1, 2, 3. This making sense?
Yeah.
Okay? All right. Well, how many different choices do I have to put in the 100 spot?
5.
Looks like 5. I could put any of those numbers there, it doesn't matter, right? How many digits then could I put in the 10 spot?
5.
I could put 5 again probably, right? Okay. Now how many digits could I put in the 1 spot?
5.
Nope, because it said one keyword there.
Even.
How many even 3-digit, for this 3-digit number to be even, it has to end with an even number, right?
Yeah.
So I only have how many choices then for that last spot? I only have 2 choices. I gotta put the 4 or the 6 there, so I only have 2 choices for that last spot.
Okay.
So whatever, 50, 50's your answer there. So, but that's how I would do that again. All right. Again, repetition is allowed. So
Will you clarify that on the test?
yes, yep, it's always clarified. So,
So
Zach?
if repetition wasn't allowed, you could use like.
if you could still do this, if repetition wasn't allowed, you could still do this. Yes. But if you wanted to use NPR, you could do 5P2 because of any of the 5 digits. But, well, that'd make it tough
Yeah. Like how do you know which?
because then you'd have to know what you put here and that would, yeah. So that would be a little bit harder.
So how do you know when to?
So, you got 2 possibilities here. So that would actually leave, I would almost go 4 then 3 there. Almost kind of work backwards in a sense. I don't know. I think that would work. So I still got 2 choices for this one. If I pick an even number to go there, then I'd have 4 choices left for here and then 3 for there. Alright, any others?
Like the
Yep.
2, we use like 2 to the 8, 3 to the 8 there. Do we just know when to like take it to a power? When it's not?
Well, you're kind of doing this.
Yeah.
How many ways could you answer the first question?
5.
2. Well,
Oh, well that.
for the true false.
Yeah, true false.
2 ways for the first question. 2 for the next. 2 for the next. 2 for the next. 2 for the next. So it's like you put 8 blanks up there and you ask yourself how many different ways could I answer the first question, next question, next question, next, and you end up with 2 times 2 times 2 times 2.
Same numbers, that's all it is.
So you can just, it's quicker to just do 2 to the 8.
Alright.
Yep. On number 2, it'd be quicker to do 2 to the 8.
How would you do B for that?
If it is all right to leave questions unanswered, true, false, or leave blank. 3 to the 8, yep, because each one has 3 possible ways that you could answer the question. A true, a false, or a blank. So 3 times 3 times 3 and so on, 3 to the 8. Okay? Alright.